Good afternoon everyone. This is Tushar Das Patnaik, lecturer in metallurgy, Odisha School of Mining Engineering, Keonjhar. For the next 25 to 30 minutes, I will be taking your class on mechanical metallurgy, chapter 9, that is wire drawing. The subject code is MTT 602. Initially, I will outline the syllabus that is there in as prescribed by SCTVT. Then we'll move further with the content and the subject. Okay. This is the syllabus as prescribed by SCTVT. 6th Sem subject, obviously, metallurgical engineering. First is explain the elementary principle of wire drawing. Second, classify the defects of wire drawing. This is as prescribed in the syllabus. First is elementary principle of wire drawing. Second is defects of wire drawing. Okay. We'll start with elementary principle of wire drawing. Then we'll move further with the defects. Okay. Look at this picture. During our childhood days, we used to do this kind of stuff. Putting a chewing gum inside our mouth and pulling it using one hand, isn't it? Pulling it using one hand like this child. If I compare this chewing gum with a metal, suppose a metal piece is there and I put one end inside my mouth and I try to pull it. I will try to make it a wire. This child, it's trying to make it thinner, isn't it? That thing I'll do. I'll put a metal piece and I'll try to pull it. I will try to make a wire out of it. Obviously, with mouse and with the hand, I can't do it. But if I use some mechanical stuff, then I can use it. Isn't it? Okay. So like this, if I use a metal rod and try to reduce its cross section successively and will try to convert it into a wire, the whole process is called wire drawing. The whole process is called wire drawing. So what will the definition? If we can deduce out of this, a successive reduction of a solid rod or bar by pulling is called wire drawing. Okay. I've already mentioned, I've already told you the definition of it. The definition: the reduction diameter of a solid bar or rod by successive drawing or pulling is known as bar, rod or wire drawing. You relate this picture with the mechanism of it. Okay. This is the solid rod. Suppose this is the solid rod. Suppose this die is the mouth. This is the hand. Okay. Or jaw. The fingertip is the jaw. Where by using this I'm pulling it or drawing away from the mouth or drawing away from the die. So die acts as mouth, chewing gum acts as this rod, this jaw acts as the finger, right hand finger. Okay. So by drawing this, there will be reduction in the diameter. Initial diameter is this much. The final diameter will be this much. There is reduction, obviously. The reduction in diameter by successive drawing is called wire drawing. These are the equipment that is used in case of wire drawing. First is, this is the draw head or draw bench. It is also called draw bench. It's a die holder. This is a die. And this is the solid bar or rod. Okay, do you understand the process? By using the die, we are reducing the diameter of the solid bar so that it can be converted into a wire. This is wire drawing. Conversion of bar or rod into a wire is wire drawing. Yes, as simple as that. Okay. Why we study wire drawing? What is the application of it? What is the application of wire drawing? Look at the pictures. We use it daily. This is a day-to-day stuff. The electric cable was used in case of wiring. This is a fence. Isn't it? Wire stock. It is used in fence. This is screw, nail, rivets, isn't it? These are produced by wire drawing. I have just mentioned these 2-3 stuffs. There are n number of stuffs that is being made using wire drawing. It has enormous application. I have mentioned only 2-3 stuff, important stuffs, very general stuffs. This is the biggest gift of wire drawing, electric cable. Okay, so to study wire drawing is justified because it has very important application. We will go for the mechanism of wire drawing, how it is done. Basically, we have only studied, I have only explained briefly. Now we study the mechanism of it, how it is actually done in a plant or in an industry. Look at this picture. These are the same pictures, only the view is same. This is the top view, this is the side view of it, cross-sectional view obviously. Look at this picture, can relate to this picture also, same pictures. This is a wire rod. It has been coiled using a draw block. This is the speed control wheel. This is the die. This is the finished draw block where the wire gets coiled again. Look at the steps. This is the final coil where the wire gets coiled. That means there is a drive here. It's a motor and drive which drives this draw block. When the rod or the wire comes out of this die, its length increases. Why length increases? Because diameter reduces. That is why the length increases. Isn't it? The length increases. As the length increases, the speed also increases. So this drive that is connected to this draw block must sync with the wire coming out of this die. Otherwise it will get slipped out of this draw block and wire drawing won't happen, coiling won't happen. So the speed of rotation must be synced with the wire coming out of this die. Okay, can you get it? This is the coil, initially coil, rod has been coiled. This is a die. So wire, same stuff. Again, for your understanding. The die, this is the wire. To pull the wire using a draw block or bull block. What will happen? This rod will get converted into a wire. This is the side view of it. The coiling, this is rotating. The wire is coiling. You can imagine electrical cable, how it is coiled. Okay. In this way it is coiled. Okay. One disadvantage of this process. What is the major disadvantage? Suppose I provide you with a 6 mm rod. I tell you, go and bring me 0.5 mm rod using this draw bench system. Using this wire drawing equipment, bring me one coil of 0.5 mm wire or 1 mm wire. How can I do it? Through the die with single pass. Like I passed for a single time. This is the 6 mm input. At one go I can't get 0.5 mm wire, because there will be severity of deformation. Die damage might happen. The rod might fracture. So it has to be successively reduced. It has to be stepwise reduced. I have to use 3-4 dies or 3-4 systems. 6 mm to 5 mm, one coil, then 5 mm to 4 mm, one system, 4 mm to 3 mm, one system, 3 mm to 2 mm, 2 mm to 1 mm, 1 mm to 0.5 mm. In this way, if I use 5 different systems, I can convert smoothly defect-free wire out of 6 mm rod. Do you get me? For that, if I use 5 different systems, I need greater space, more space. 5 different drives is required, 5 different motor is required. Energy consumption will be more. So what will be the remedy? Engineers found out a solution. This is the solution. They used a stepped cone multiple pass wire drawing. I've already mentioned, you can't get wire out of single pass. You have to pass it 3-4 times so that you can get desired wire. Like I explained you, if I want 1 mm wire, I can't get at a single go 1 mm wire out of 6 mm wire, 6 mm rod. I have to pass it 3-4 times so that I can get 1 mm wire or 0.5 mm wire. This has been done in a limited space using a single drive, a single motor, using this stepped cone multiple pass wire drawing equipment. This has been stepped, 1, 2, 3, 4. It has been connected with a shaft that is connected to a drive, single drive that's rotating the stepped cone. But look at the arrangement, it has 4 dies, so that multiple pass can happen. How I'll explain. Suppose I have 6 mm rod. I want to reduce the 6 mm rod into 3 mm rod or 2 mm rod. How can I get it? 6 mm my input, I put it here. Let's say the reduction in each die is 1 mm. Let's say, suppose reduction in each die is 1 mm. Okay. So I'll get 5 mm here. This 5 mm will be input for the die 2. In the output we will get 4 mm. This 4 mm will be input for the die 3. The output of die 3 I will get 3 mm. The 3 mm will be input for the die 4, and the output will get 2 mm wire. Using this stepped cone, I can convert at one go 6 mm rod into 2 mm wire. And I am using limited space. I don't have to use 5 different or 4 different systems. I am using one drive. I am using 4 dies in a stepped cone. Now the question arises, why stepped cone? Sir, why not a single cylinder or a single cone? Why a stepped cone? The reason being is, when the wire comes out, the length increases, the speed increases. To accommodate that, to accommodate the increase in length and increase in speed, it has to be stepped. Otherwise, it will get slipped. Coiling won't happen. Coiling won't happen, wire drawing won't happen. So stepped cone is done to accommodate increase in length and increase in speed of velocity. Okay. Why? There's a question always comes in the exam. Why stepped cone multiple pass wire drawing is economical than normal draw bench wire drawing? This is the reason. I'm saving space, I'm saving energy. If I would have used 4 different systems, 1, 2, 3, 4, then I would have required 4 different space, 4 different drives. Here I can do it with one system, one drive, and I am saving space, I am saving energy, I am giving profit to the company. Okay, I hope you can understand. So wire drawing die, in case of wire drawing, die is very very important. Die is very very important because die goes through severity of deformation. Okay, these are the cross-sectional view of a die, drawing die. This is the steel casing, this is the bale region, this is the approach angle, this is the bearing section, this is the back relief section, this is the carbide nib. What is the use of it? I'll briefly explain. The bale, this bale provides lubrication. Lubrication is essential to get the wire drawn through the die. Lubrication is extremely essential, otherwise surface crack will generate. Next is approach angle. The approach angle is where maximum reduction takes place. Here maximum reduction takes place. This is the bearing section. What does this bearing section? Bearing section produces a frictional drag. Frictional drag so that surface damage is removed. Surface damage is removed, or it will generally it will polish the wire. This bearing section. This is the back relief. Look at this. This is the back relief. Back relief. It provides, when the metal wire comes out of it, it gets expanded. It gets expanded, so that in case if by any technical problem, if wiring stops, the wire doesn't go back. If it goes back, then what? Abrasion will happen. The die might get eroded. Okay, this back relief, what it does is it holds. It stops abrasion. Okay, this die nib is made out of cemented carbide or silicon carbide, tungsten carbide. Carbides are very very strong, so that is used. That is protected by steel casing. The die has been protected by steel casing. This is basically whole arrangement of a wire drawing die. You have to remember the figure. That's very important. In exam, generally they ask, explain different parts of wire drawing die, explaining its functions. So you have to remember every terms that comes across. This wire drawing die. This is the flow chart of the process of wire drawing. Okay, first is rolled coil or rolled rod. Next is cleaning. Cleaning is essential to get defective product. Next is descaling. Scaling means formation of oxide on the surface of the wire. Oxides are brittle in nature, so descaling step has to be there so that oxide doesn't get included inside wire. Otherwise it will create brittleness in the wire. Next is annealing. Annealing is done to remove residual stress and to increase ductility. Annealing is done to increase ductility and to remove residual stress. Where does that come from? That comes from the previous rolling of the rod. When the rod were previously rolled, there might be some kind of residual stress. That is reduced by annealing. You must study cold work annealed cycle of metalworking to understand the process in a better way. And you must refer to YouTube. You must refer to YouTube to get better idea how real time, how in a plant it works. Next is lubrication is very important. Next is drawing. Lubrication is essential, I told you. Next is drawing. Next is wire drawing defects. The two basically, there are many number of defects, but I have mentioned 2-3 defects, very important defects. First is seams, slivers and pipe. Number 2 is center burst or chevron cracking or cupping. Okay, these 3 stuffs are same. Center burst, chevron cracking, cupping are the same. First is seams, sliver and pipe. Seams is a welding kind of stuff. Look at the line in a pipe. These are called seam. Slivers is like some metals is taken away from the wire. That is sliver. So pipe means there's a hole or pipe inside a wire. What is the cause of it? There is no cause during the process. The cause comes because of the defect inside the starting rod. If the starting rod is defective, the wire will be definitely defective. So what is the remedy? Defect free input must be there, or defect free rod must be used. Next is center burst or chevron cracking. This defect will occur because of low die angle at low reduction. If reduction is low, the whole metal or whole rod try to gush through the center of it. So that center will develop tensile stress, like somebody is pulling it with heavy stress. So this V kind of chevron means V kind of safe. So this V kind of cracks gets generated all along the rod. This is an internal defect, not visible with naked eye. Very important. Very important defect. There's assignment questions for you. Explain the principle of wire drawing with neat sketch. Sketch is very important, as I mentioned. Draw neat sketch of cross section of wire drawing conical die and explain the technical terms you come across while drawing it. What are wire drawing defects? Write down the causes and remedies that I explained. You write it down. What are the application of wire drawing? I have shown you in the first slide. Why stepped cone multipass wire drawing is economical than drawing best? I have already told you why this is economical. Stepped cone is economical. Okay. Now I think we have understood all the wire drawing subjects in briefly in brief. I'll try to revise it for you. We started with a children drawing chewing gum. We try to relate with that with wire drawing. Wire drawing same stuff. If you relate a student or a children drawing chewing gum, then you can relate wire drawing. Then we went for the definition of it. Then we went for the mechanism. Then we went for the application part. Then we went for the process, for the steps. Then we went for defects, different defects like seam, sliver, and and center burst or chevron cracking or cupping, same stuff. Next we went for the assignment questions for you. You must do it. Any doubts, you can ping me on this number 98611 You can mail me on tushar.nitrkl@gmail.com or osmetallurgicalengineer@gmail.com. Thank you.
झीटीए तो माटी आम सामाजिक और पारिवारिक जीवनर मूल कथाटी से माने आगकू गले आगकू जीव संसार आम झील मैंने आ पुओंकठू पछरे नाहंती एबे तो बदली गलानी समय बदली गलानी जुग से झील मानकू आहुरी आगकू नहीं आत्मनिर्भरशील और स्वावलंबी करने ओडिशा सरकार सुदक्षा योजना रे सरकारी आईटीआई माध्यम संपूर्ण मागणारे जोगई देउछंती सबु प्रकार उत्कृष्ट मानर वैषयिक ज्ञान कौशलर तालीम एबे आम झील रहिबे सबुठू आगरे सबुठू उपरे
मु सफल मु कुशली मु सुदक्षा